Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutewa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 8 still on differential calculus, and then we have 8.1 there. It says determine f prime x from first principles if f of x is equals to 3x cubed plus 2x, right? So the first thing that we want to do is use our rules so that we have the confirmation of what our final answer should be. Then that's 6x plus 2, because 2 jump down to multiply the 3, that's 6. And then obviously, if we are deriving a variable with only an exponent of 1, then the solution is the coefficient, right? Then at this point, we know f of x is equals to 3x squared plus 2x. But then our fx plus h, that means wherever we see x, we have to substitute or replace by x plus h. Then that's 2 and then x plus h like that. Now, having to expand this is x squared plus 2xh, then plus h squared. And then here we will have 2x and then plus 2h, right? So if we multiply with the 3 inside, that's 3x squared plus 6xh plus 3h squared plus 2x plus 2h. So no common factors here. That means you do not add anything up, right? So at this point, we want to solve for our f prime x. We say f prime x is lim h approaching 0, fx plus h minus fx, and then over h. Now at this point, you want to say lim h approaching 0, then take this whole expression here, write it here, then 3x plus 6xh plus 3h squared plus 2x plus 2h, then minus the expression for f of x, which is just 3x squared plus 2x, right? Then over h. Now at this point, we know that this will cancel out the 3x squared and the 3x squared, the 2x and the 2x there. So that means we are only left with a lim h approaching 0. So the 6xh plus 3h squared plus 2h and then over h. Now looking at these three terms, we can see that there is a common factor there of h. So what do we do with a common factor? We factor it out, and then we are left with 6x plus 3h plus 2, and then over h. This point, we know the h and h will have to divide out, and then we are left with 6x plus, where there's h, we put 0, and then here we have 2. So this is going to be, therefore, f prime x is equals to 6x plus 2. Are we confident about our solution? 100%, because we have confirmed it up there already, right? So that's how you were supposed to tackle that question, all for an easy peasy 4 marks. Oh, so this one, they actually made it 4 marks. They were a bit stingy with this one. Then 8.2, determine dy dx if y is equals to 4 over root x minus 8 over root x plus pi x to the exponent of 3. Now, this is a very nice question because a lot of people get confused if they try to throw in other variables into the mix, like your pi and what so not. So note this, the dy dx means that we are deriving y in terms of x. So whatever that they put in there, you'd simply treat it as a coefficient, right? So that's 4x. Obviously, remember our commandments is that we have to move it from sub form to exponential form. So we cannot derive while it is in sub form, and then we cannot also derive while it is still a denominator. So it has to come out from here So this is x to the exponent of 1 over 2, obviously. And then we have the 8. So this one, first, if we take it out from there, that's 1 over 2 like that. So nothing wrong with the pi there. But then let's further write it in standard form. So this needs to be up there. So that's x to the exponent of 1 over 2. So you see, whenever it switches from denominator to numerator, the sign there of the exponent is affected. Then plus pi x cubed. Now the pi here is the same as having the 4, the 8, or whatever number there. The pi there is simply just a coefficient, right? Then at this point, we can say that our expression or our equation is prepared for derivation. So we go dy dx. And then again, this jumps down to multiply the coefficient. It's going to be 2. But then if we subtract here the 1 from that, it's going to be negative 1 over 2. And then if this jumps down to multiply the coefficient, that's positive 4. And then x, if we subtract 1 from here, then it's going to be negative 3 over 2, right? And then from here, the 3 jumps down to multiply the coefficient, which is pi in this case. So it will be 3 pi. And then x, if we subtract 1, that's 2, right? So just like that, you have your solution. You leave it like that, it's complete. Okay, so for 8.3, they say the graph of g of x is equals to ax cubed plus b over x is equals to 96. Has a minimum value at x is equals to 4. Calculate the values of a and b. Now check, they said it has a minimum value. And then when we are looking at this expression from the ax squared here, we can tell that this is a parabola. So a parabola has a minimum value if it is a concave up graph, right? So remember, concave up graph means that it will have a minimum value here, right, at the turning point. So now they're saying that the coordinate of those ones, it's occurring at x is equals to 4, but then it produces a y value of 96. So that means the turning point at that position would have to be 4 is to 96, right? So now we are asked to calculate the values of a and b. Now this is one thing that you have to note in terms of the original equation, but then again, they led us to this point, which is the turning point. If we were to note what is the gradient at the turning point, we know that the gradient at the turning point is 0. So if we had to put a line here, a tangent that will intersect or that will touch that point here, we know that the gradient of this line will be parallel to the x-axis, meaning that it will have a gradient of 0. So two things that we are going to use. We are going to have to use these two coordinates, substitute them into the original equation, and then derive this equation here to form the gradient function, and then have to substitute the 4 here so that we can find the gradient at that particular point, right? So to go about solving this one, number one, we have our g. When x is equals to 4, should be a, where there is x now, I put 4, so 4 square. Then plus b, where there is x, I put 4. So this is the meaning of that. But then remember, the value at g when x is equals to 4 is 96. So I can just substitute 96 there. Then what is 4 square? 4 square is 16. So we have 16a here. Then plus b over 4, right? Now at this point, we want to make b the subject of the formula. So what can we do? We can just try to take this 16a over to that side. So we have 96 minus 16a is equals to b over 4. This point, we can try to cross multiply with that 4 there. So if we say 4 multiplied by 96, we have 384. If we say 16 multiplied by 4, we have that minus 64a, and then is equals to b, right? Now we can say this is our equation number 1. Now equation number 2, what do we do? Just go g of x number 1. Let's have our ax, and then first let's kind of write it in a way that will be prepared for derivation. So this will be bx to the exponent of -1. Now, having to derive, we have g prime x will now be equals to 2ax, and then plus, not plus, negative, because it's -1 multiplied by b. So it's supposed to be minus bx to the exponent of -2, right? Then, okay, now that we have that, what can we do? We can say our x needs to be 4 because that's the point of contact. So this is between this tangent that we've drawn here to this parabola here. Then this is 4, and then 2, and then 4 minus b, where this x we just put 4, like that. And then remember, at that point we said the gradient should be equal to 0, because note, this tangent that we've put there is parallel to the x-axis, and then at that point of contact, the gradient of the tangent is equal to the gradient of the curve that we've drawn there. So it's 0, and then here we have 2 times 4, that's 8a, and then this one here we have minus b. It should give us 16, so that's 1 over 16, so we have the 16 over here, right? And then having to solve this, we can make b the subject of the formula again by taking the negative b over 16, or the -1 over 16b over to this side. So that's b over 16 is equals to 8a. So we came here, and then if we cross multiply this, the b is equals to, the b will be equals to 16 times 8, that's 128a. So we can call this equation number 2. Now at this point, we know what we should do: equate equation 1 and equation 2. So let me erase this part here. So to find, now it becomes very simple to find our values for a and b. So now we have equate equation 1 and equation 2. So equate, and then this will be 384 minus 64a is equals to 128a. Now we can take the -64 over to this side. That's 384 is equals to 128. So 128 plus 64, that's 192a. And then if we divide both sides by 192, our a becomes 2. And then in order to find b, we can substitute in any of the equations, whether equation 1 or equation 2. It's your choice, but then the simpler one is equation number 2. So we can just go 128, and then where there's a, we replace with 2. So what is 128 multiplied by 2? That's 256, right? So our value for A is 2 and our value for B is 256. That's how you were supposed to go about answering that question for a total of 6 marks, right? So with all that being said, please play the video as many times as possible and just try to understand the approach that I took into solving this question here, especially that 8.3. So it all boils down to the fact that every time we are trying to answer these questions, we must always substitute into the original equation and also substitute into the derivative equation. And then we have to kind of figure that out simultaneously up until we get our values, right? So with all that being said, guys, please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.